Download this code from codegive.com, link in the description below. Certainly. The problem arithmetic slices 2, subsequence, leetcode 446, is a classic dynamic programming problem that focuses on finding arithmetic slices in a given list of integers. An arithmetic slice is defined as a subsequence of at least 3 elements where the difference between consecutive elements is constant. Problem statement. Given an integer array A, return the number of arithmetic subsequences of length at least 3. Key concepts. 1. Subsequence, a sequence derived from another sequence where some elements can be deleted without changing the order of the remaining elements. 2. Arithmetic sequence, a sequence of numbers such that the difference between consecutive terms is constant. Approach. To solve this problem efficiently, we can use dynamic programming with a hashmap, dictionary in Python, to keep track of the number of arithmetic subsequences that end with a specific element and have a specific common difference. Steps. 1. Initialization. Use a list of dictionaries to record counts of arithmetic subsequences for each endpoint. 2. Iterate through the array. For each pair of indices, j, I, calculate the difference d equals ai, aj. 3. Count subsequences. For each I, update the dictionary for ai with the number of valid subsequences that can be formed using aj. 4. Update count. Keep a cumulative count of all valid subsequences of length at least 3. Code implementation. Here's a Python solution to the problem. Explanation of the code. 1. Initialization. We create a list dp where each element is a dictionary. Each dictionary will store the counts of valid subsequences that end with the current index and have a specific common difference. 2. Nested loops. We loop through each pair of indices, j, I, where ji. For each pair, we compute the difference d. 3. Counting subsequences. Count underscore j retrieves the current count of subsequences ending at aj with the difference d. We then increment the count for ai with the number of ways to extend aj to ai. 4. Total count. We keep a running total of valid subsequences of length at least 3. Complexity. Time complexity, \o, and _2, where \n is the length of the input array A. This is due to the nested loops iterating over pairs of indices. Space complexity, \o, and \k, where \k is the number of unique differences, as we store counts in a dictionary for each index. Conclusion. This approach efficiently counts the number of arithmetic subsequences in the input array. It leverages dynamic programming and hashmap data structures to keep track of potential subsequences, ensuring that we can find the solution in a reasonable time frame even for larger arrays. Certainly. The problem arithmetic slices 2, subsequence, leetcode 446, is a classic dynamic programming problem that involves finding the number of arithmetic slices in a given integer array. An arithmetic slice is a sequence of at least 3 numbers that form an arithmetic progression. Problem statement. Given an integer array A, return the number of arithmetic slices of length at least 3 in A. Definition of arithmetic slice. An arithmetic slice is a sequence of numbers where the difference between consecutive elements is constant. For example, in the sequence 1, 3, 5, 7, the difference is 2, and it forms an arithmetic slice. Example. Input asterisk. Output asterisk. Explanation asterisk. The arithmetic slices are 2, 4, 6, 4, 6, 8, 6, 8, 10, 2, 4, 6, 8, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 6, 10. Approach. 1. Dynamic programming with hashmap. We can use a hashmap dictionary to keep track of the number of arithmetic subsequences that end at each index for each possible difference. 2. Iterate through the array for each pair of indices I, j, where ij, calculate the difference d equals aj, ai. 3. Update hashmap for each pair. Update the count of sequences that can be formed using this difference. If there are already k sequences ending at I, then k new sequences can be formed ending at j. 4. Count all valid sequences. Whenever a new sequence of length equals 3 is formed, increment the total count. Python code. Here is the Python implementation of the above approach. Explanation of the code. 1. Initialization. We create a list of default dict, int, for dynamic programming to store counts of arithmetic slices for each index. We also initialize a variable total underscore count to keep track of the total number of valid slices. 2. Nested loops. We loop through each possible pair of indices, I, j. The outer loop iterates over j, and the inner loop iterates over all ij. 3. Difference calculation. For each pair, I, j, we calculate the difference d. 4. Count update. We update the count of slices ending at j using the count from I, and we also add any valid slices formed by previous subsequences. 5. Final count. Finally, we return the total underscore count, which gives the number of arithmetic slices found. Conclusion. This algorithm efficiently counts the number of arithmetic slices in an array using dynamic programming and hash maps, ensuring that the solution runs in O(n)(2) time complexity while maintaining clarity and correctness.